Welcome to this explainer. If you've ever stood in front of a high-powered stereo and wondered exactly how a tiny, completely silent electrical signal somehow transforms into room-shaking sound, well, you are in the perfect place. Today, we're taking a deep, really fascinating dive into the anatomy of the Techno Masterit's STAS40 Audio Amplifier IC. We're going to map out the complete signal journey from raw electricity all the way to that final acoustic punch.
Okay, let's dive right into our roadmap for today. We'll start with the STS40 Amplifier IC, move over to powering the system, trace the inputs, explore the speaker array, and finally, bring the whole thing together to create the final sound.
Part 1. The STAS40 Amplifier IC, essentially the biological brain of the operation.
So, looking at the complete schematic for the Techno Master STAS40, it's kind of like looking at a living organism, right? That massive, dark, rectangular block sitting dead in the center, that is the absolute biological brain. Every single surrounding path and component is entirely dedicated to serving that one central chip.
To put it simply, the STAS40 is your Central Audio Amplifier Integrated Circuit, or IC for short. It acts as the primary hub, the grand conductor of this whole electronic orchestra. It takes in those weak, quiet little audio signals, like what comes from your phone or a turntable, and orchestrates the immense electrical power required to blast that audio out to the physical speakers, hopefully without blowing the roof off. Just notice the sheer connectivity of this chip. We've got a staggering 30-pin central layout. That's 15 delicate pins running down each side, locking it right into the board's nervous system. And as it's labeled right there on the left, it's highly specialized to handle 4 input lines and manage 4 output zones. It's an incredibly specialized piece of hardware built for precise stereo control.
Part 2. Powering the audio system. Let's look at the heartbeat.
Now, even the most advanced brain is completely useless without a pulse, right? Down at the bottom left corner, you've got those distinct red and black wires. That is where the raw energy enters our system. It acts as the absolute lifeblood, flowing all the way across the bottom edge toward that massive green filter capacitor on the right.
And right next to those wires, we see its specific fuel requirement, 8 to 22 volts of direct current. This is absolutely crucial. This amplifier needs a very robust, very specific range of fuel to wake up. Too little voltage, the IC literally starves. Too much, and you risk completely frying that delicate internal architecture.
So as that raw 8 to 22 volts of power rushes in through the positive red and negative black terminals, it doesn't just slam straight into the brain. Actually, scratch that, it can't go straight in. It hits that large green cylinder first, the filter capacitor. You see, raw electrical power isn't always perfectly smooth. It can have these microscopic spikes and drops. This massive filter acts like a giant reservoir and purifier. It scrubs that electrical pulse so that by the time the power actually hits the STAS40 IC, it is perfectly stable. That's what ensures your audio doesn't have any nasty buzzing or hums. All right, part 3. Inputs, LEDs, and ceramics. The nervous system. Now that our brain is powered up, we need to trace the nervous system, those delicate pathways carrying the actual audio signal. If you follow the path labeled Input L near the top left, you'll see it sweep right into the chip. Also notice the vibrant red signal LEDs at the top and bottom of the IC, along with those small, orange, disc-like ceramic components lining the bottom pathways.
Let's see how this all builds step by step. First, your unamplified audio sneaks in via designated paths like Input L. Second, as that signal flows, those top and bottom signal LEDs light up. I absolutely love this feature. It gives you immediate visual confirmation of an active status. You can literally see the music pulsing through the circuit. And third, those tiny orange ceramic components act as microfilters, stripping away any high-frequency interference along the bottom pathways before the signal ever even enters the IC.
Part 4. The 4-speaker array. This is the mouth of the system.
Okay, we've powered the system, we've filtered the inputs. Now for the thrilling part. We arrive at the mouth of the system, the exact moment where electrical signals physically transform into the sound waves we actually hear. Checking out the far left and right edges, we're greeted by this beautifully symmetrical layout. 4 distinct speaker cones, and standing guard right next to them, 4 large capacitors waiting at the literal edge of the board.
And this brilliantly illustrates the flawless stereo symmetry designed into the Techno Master. Over on the left channel, routed via output L, we have left speaker 1 and left speaker 2, perfectly paired with 2 2200 microfarad capacitors. Mirroring this exactly on the right channel, via output R, we have right speaker 1 and right speaker 2, also paired with 2 2200 microfarad capacitors. It is total, balanced audio perfection.
Now you might be wondering, why stick more capacitors all the way out here by the speakers? Well, those four distinct 2200 microfarad capacitors act as final power buffers. Think about it. When a massive heavy bass drop hits in a song, the speakers suddenly demand a huge spike in power to push the air. The main power supply honestly might not react fast enough. But these capacitors, sitting right next door, they instantly dump their stored energy to provide that maximum acoustic punch without any distortion.
Part 5. Creating the final sound.
So, let's bring the whole shebang together. Here is the complete micro-narrative of how sound is born in this circuit. It starts with raw 8 to 22 volts of DC power rushing into the board, where it's immediately cleaned and stabilized by the large green filter capacitor. At the exact same time, delicate audio input signals slip past glowing LEDs and filtering ceramics straight into the 30-pin STAS40 IC brain. The IC massively amplifies this signal and shoots it out to the edges of the board. There, those 2200 microfarad capacitors buffer the heavy amplified output, ensuring a smooth, powerful delivery as those four speakers physically thrust back and forth, ultimately delivering that roaring stereo sound right to your ears. It really changes how you look at everyday electronics, doesn't it? Next time you turn up the volume and get totally lost in the emotion of your favorite song, I want you to ask yourself, do you realize you're actually hearing a complex, highly synchronized symphony of discharging capacitors, perfectly stabilized DC voltage, and precise 30-pin micro-routing? The technology driving our art is honestly an art form in itself. Keep exploring, everyone, and thanks for joining me on this explainer.